You know that feeling when you're juggling limited resources, like time or money or even just ingredients, and you're trying to get the absolute best possible result? Well, today we're diving into a super powerful mathematical tool designed to solve exactly that problem. It's called linear programming, and it's all about making the optimal choice. So, to kick things off, let's start with a really simple puzzle. It's the kind of challenge you might see in a business, maybe even in your own life, and it perfectly sets the stage for everything we're about to get into. I mean, this is the big question, isn't it? When you can't have it all, how in the world do you decide what to do to get the very best outcome? This isn't about guesswork, it's about having a system. Okay, let's make this totally real. Picture yourself running a small bakery. You can make two kinds of cakes. Now, each cake needs a different amount of flour and sugar, and you get a different profit for each one. The catch? You only have so much flour and sugar to go around. So, how many of each cake should you bake to make the most money? That's our puzzle. To solve this bakery puzzle, we need to translate it into a language that math can actually work with. And it really all comes down to just three core building blocks. These are the three key ingredients we have to define. We've got our decision variables, our objective function, and our constraints. If you can get these three things right, you are well on your way to finding that perfect solution. First up, decision variables. What are the things you actually have control over? In our bakery, it's super simple. It's the number of chocolate cakes we bake and the number of vanilla cakes we bake. Our job is to find the perfect number for each. Next, what's your ultimate goal? What are you trying to do? This is your objective. For our baker, the goal is crystal clear. Make as much profit as possible. We can even write this as a simple formula. The profit you make on cake 1 times how many you bake, plus the profit from cake 2 times how many of those you bake. Simple as that. And finally, we've got the reality check. What's holding you back? These are your constraints. You have a limited amount of flour, right? You've got a limited supply of sugar. And of course, you can't decide to bake, -5 cakes. All of these are rules you absolutely have to follow. All right, so we've laid out our problem. Now, how do we actually find the answer? Well, for a simple problem like our two-cake bakery, we can literally draw a picture of the solution. I want you to imagine a piece of graph paper. Let's say the number of chocolate cakes is on the bottom axis and the number of vanilla cakes is on the side axis. Each one of our limits, the one for flour, the one for sugar, actually becomes a straight line on this map. Now, this is where it gets really interesting. See that shaded area where everything overlaps? That's called the feasible region. Every single point inside this shape represents a baking plan that's actually possible. Any combination of cakes you can possibly make, given your ingredients, lives right inside this region. And here it is, the magic trick. This is the crucial insight. You might think we'd have to check every single point inside that shape, but we don't. A fundamental rule of linear programming says that the single best answer, the plan that gives us the absolute maximum profit, will always be at one of the corners of this feasible region. This makes finding the solution so much easier. So that graph is awesome for two types of cakes. But what if our bakery made, say, 50 different products with 100 different ingredients? You can't exactly draw a 50-dimensional map, right? We're going to need a more powerful tool for that. So let's just compare these two. The graphical method we just looked at is fantastic for visualizing things, but it's really limited. For the complex, messy, real-world problems, we use something called the simplex method. Think of it as a powerful algorithm that does the same job, but for hundreds or even thousands of variables at once. So how does it work without a map? Well, the simplex method is just incredibly clever. It starts at one corner of the problem, mathematically speaking. It then checks its neighboring corners and jumps to whichever one improves our profit. It just keeps hopping from a good corner to an even better corner until it finally lands on one where there are no better corners to jump to. And right at that moment, it knows that's it. That's the optimal solution. Okay, so this is obviously about way more than just baking cakes. This mathematical engine is actually one of the hidden forces that quietly optimizes the incredibly complex systems of our modern world. And this really shows you the kind of impact we're talking about. From logistics and supply chains to finance and technology, linear programming is a huge part of what's called prescriptive analytics. It doesn't just describe what happened, it uses data to prescribe what you should do to get the best result. Just think about it for a second. A global shipping company trying to figure out the best routes for its fleet to save fuel? That is a massive linear programming problem. Or what about a financial firm trying to build an investment portfolio to maximize returns while keeping risk below a certain level? Or even in tech, where it's used to allocate server resources to different AI tasks. It is absolutely everywhere. So, the next time you're facing a decision with clear limits and a very specific goal, remember our baker. You're really just trying to figure out your variables, your objective, and your constraints. This way of thinking doesn't just power massive industries. It can actually bring a lot of clarity to our own choices. So, what's one thing in your life you could optimize?